Good morning, afternoon, or evening, depending on which time you're watching this episode, and welcome back to Constellation Crew here at the Charles W. Brown Planetarium. Brain too fast, mouth too slow. Anyway, so this is going to be a very interesting episode because February, the month of love, we all know what goes on in this month, and some of us are super excited for it, and some of us are terrified for it. But it all makes sense because love is not easy, and neither is space. So today is a love space episode, including both topics. But for our regular viewers, you might have noticed either a new face or a familiar face, because this is not the first time that our guest has been on Constellation Crew. In fact, she was once the host. So let us give a big warm welcome to Dayna Thompson, everyone.
Hi everyone, I'm Dayna Thompson, the Planetarium Director here at Ball State's Charles W. Brown Planetarium.
Finally a face to a name, because I talk about Dayna all the time. It's a nasty habit, but I just love Dayna. It's hard. Anyway, so Dayna, what do you do? What do you do for a living?
So here at the planetarium, I'm the director, which means that I provide support and guidance to our planetarium staff. And for the 16-meter planetarium that we have open to the public, so 16 meters roughly translates to 52 and a half feet. And that makes it the largest planetarium in Indiana. We seat about 152 people, seat over 20,000 people every year, and all of them come for free, which we're really excited to be able to do here. I also provide support for a 9-meter production dome, which used to be our only planetarium on campus since the 1960s, actually. So we've had a planetarium on campus for a really long time. The new one opened in 2014, but I've been around even longer than that with the old planetarium that was down in the basement here. And we now use that old planetarium to produce programs, pre-recorded programs, and then live programs that are educational for school groups, Ball State classes, and then public groups coming in. And I do a lot of other things too. So I collaborate with some community partners and university faculty, staff, and students on kind of innovative cross-curricular research and special events and projects. I try to promote the planetarium and astronomical events throughout the community. Actually, today we have a meeting at City Hall to talk about the upcoming eclipse that's passing through Muncie in 2024, which is really exciting. I manage our planetarium websites, our social media accounts. I create our marketing and communication materials for the planetarium. So I wear a lot of hats here. I also manage our budgets and accounts. I brought in over $130,000 in grant funding since 2014 to support our planetarium projects and upkeep. And I've designed some of the programs that we actually sell. And I brought in a lot of money from those show sales too. So we've done a lot over the years, and one of the wonderful things that we've been able to do here is hire someone new to help me, and that's our planetarium show specialist, Melanie Eisenbarger. She started in 2021, and before her, I actually scheduled over 400 planetarium events annually and managed our calendar for that. So now she's able to do that, take a lot off of my shoulders so I can really focus on some other things.
Wow. That's the dream, right? That's the goal. That's the goal. It sounds amazing. That's the kind of life. And I know I say that not having it. It sounds very busy. And everyone knows busy lives can go either way. But that's amazing and so impressive. We have two final questions really quick before we get started on the episode, but I'll just combine them into one. So why are you here? And what got you into your career?
Yeah, so as you mentioned, Nicolette, I actually did start Constellation Crew, and I was the original host back in 2020. So I've kind of gone to behind the scenes. I work with you and Kyree and all the Constellation Crew presenters on developing the Constellation Crew episodes, and then I edit them for our YouTube page. But I really wanted to kind of highlight some of the people in the department again this semester for our episodes, and so we brought in someone outside our department, actually in the planetarium field, for the last episode. This episode, I want to come in on my own for the department. And then next episode, we're going to bring in the department chair for physics and astronomy, which the planetarium is a part of. And then we're also going to bring in some other exciting guests from the department later on in the semester. And then what got me into astronomy and science in the first place? So when we talk about astronomy and science, we actually kind of incorporate it into STEM. So do you all know what STEM stands for?
Yes, we do.
So what's S stand for?
Science.
Science.
And the T?
Technology.
Technology.
And the E?
Engineering.
Engineering.
And the M?
Math.
Mathematics.
Or mathematics.
Yeah, so it's the M in STEM that got me into STEM or science, and then eventually into physics. So I was really good at math for a long time. It was my favorite subject for a really long time. And it got me into studying physics down the line, which you really need to be good at math or have a passion for math to be good at physics.
Can confirm.
Yep. So I have my bachelor's degree in physics. I have my master's degree in physics as well. And so when I saw how math could really be applied to help solve some challenging and interesting problems that scientists are facing, like string theory, I got really hooked. So I saw a PBS special, a NOVA special on string theory called The Elegant Universe. And it told the story of quantum mechanics in just this amazingly fresh and new way. And it sucked me in and kind of held my attention. And I thought, well, maybe I should be a scientist. I'm really good at math, so why not? So that kind of followed me through college and eventually led me to study astronomy and much more.
Wow.
And then kind of what got me into the planetarium field is that as a grad student, I was able to work at the university's planetarium, and giving presentations to the public and school groups really kind of showed me that there is more to science than just taking tests. It was about teaching and connecting with people. And I really like that kind of collaboration aspect of science, and being able to share a passion with someone else, with the community, and just tell stories about science and connect with people.
I resonate with both. That sounds very similar to how I'm here now as well. I just was really interested in STEM, and then it just snowballed from there. Awesome. Well, I have a question for the both of you since you brought up STEM. This is something new, and I don't know if any of our viewers have seen this either. Have you heard of STEAM?
Yeah, we try to do STEAM too. Yep.
Yeah, that one's really interesting, but I also appreciate it because in my family, most of my mom's side of the family are like artists and musicians, the more artistical side of things. And my father's side are mostly doctors and nurses. My grandfather's a pharmacist. Really love it when he talks about that. So I'm the kind of oddball going for science in general, or physics and astronomy. So it's nice to get my artistic genetics involved in something that I've been passionate about for a long time as well. So like the two passions blending, I appreciate STEAM existing. It's nice.
Yeah. So STEAM is STEM with the A added, which stands for arts.
Yep.
Yeah.
Yes.
So we collaborate with the art museum on campus. We actually just got an email today from them about collaborating on some STEAM initiatives.
Nice.
And we have like these hands-on activities that we do before our planetarium programs that try to incorporate some STEAM, some art. We have this nebula spin art, for instance, where we actually use paint to create these beautiful clouds of gas and dust in space with our planetarium guests coming through.
Wow.
Yeah.
Awesome.
So my sister is actually has her degrees in communication, and that's helped me a lot with creating some of the graphics and advertisement and the marketing communications that I do. So having kind of that experience as well has been a big help with what I do in the planetarium, because show design takes a lot of creativity.
Yeah, I would agree. Being astronomy, well, you have two Astronomy Slam champions with you today, Dayna.
We do,
Yes, our
yeah.
Astronomy Slam. Oh, there you go. There's the award itself. Beautiful. It's so pretty. I love mine too.
Love it. I love it. It still has not left my desk. In fact, I probably need to give it the third wash it's gotten this week.
I literally dust mine as well, so understandable. I get it. It's too pretty. You can't just let it sit there.
Exactly. It looks great.
Well,
Absolutely. Yeah, so with physics, we're going to talk about some interesting objects in space today. And whenever we introduce astronomy and science to our not necessarily the preschoolers that come through the planetarium, not directly anyway, but like say second grade and up, we talk about physics and what it is. And what do you usually explain physics as to people who ask? Like, what is physics?
That's a tough one. Yeah, but most of
When you study physics, what do you study?
I would say we study the why.
World. Oh,
yeah, like why or how things work, right?
Yep.
We study how things work from the really small, so I mentioned particle physics. So the really small, like particles, to the really large, like stars, and then galaxies made up of stars, and our universe made up of galaxies. So we think, physics, what does astronomy have to do with physics? Well, it's all connected, right?
Oh, for sure.
So that's what led me into getting interested in astronomy. But I really like the multi-messenger aspect of astronomy because we're in the era of multi-messenger astronomy, right?
Mm-hmm.
So that means what kind of information can we get from these astronomical images and objects that we're or what kind of information can we get from these astronomical objects that we're studying out in space?
Exactly right. We did that for modern topics, or I forgot the long version of the title, but I think it's modern topics in astronomy. There we go. Something like that. We did multi-messenger as a unit once, and that was actually a very awesome thing to learn about because sure, I've heard it before and I'm like, oh yeah, I know what it means. It's fine. But when you learn it in depth, it's very interesting. And for our viewers, Dayna said it really well. But we all remember that light comes in different wavelengths and forms. There's the visual and optical, and of course there's like ultraviolet and radio. That's multi-messenger. So instead of just looking at
well what I was asking is what do we get from objects? So what kind of information, what forms of information can we get? So light is one of them.
Yeah. Oh, okay, yeah.
What else, what other information, pieces of information can we get from these objects? So there's light.
Yeah.
There's particles.
Okay.
So elementary particles like electrons and neutrinos, right?
Yeah.
But then there's this new thing, newer anyway, that's recently been observed.
Gravitational waves?
Yeah, absolutely. Yeah. So we can now observe the universe with all these different types of bits of information, gravitational waves, particles, and light, which has really been around for a long time for helping us understand the universe. And we're going to explore a lot today. But now we have gravitational waves, which is just huge, right? So yeah, that's exciting. That's exciting to me.
For the sake of our love-filled episode, because we want to get around to talking about all the heart shapes in space, if you would like to learn more about gravitational waves for our viewers, check out the LIGO telescope observing system. Like, it's really hard to describe. Yeah. So LIGO, so check that out. That is one of the most popular gravitational wave observing systems, and it can tell you more about it. But like I said, we're doing a love-filled episode, but let's remember where we are. We are using Stellarium today, or Stellarium, however you would like to pronounce it, and we are here in Muncie, facing south, both physically and in Stellarium. So you might notice some very popular objects in our sky. We've gone over a lot of them today, in general, in most Constellation Crew episodes, we've gone over them a lot. The days blur together. Anyway, so there is actually something very cool in the sky, as you're seeing right now, viewers, that I think is really awesome. I have yet to be old enough and conscious enough to see this happen. Usually I see it right before sunset or right before sunrise. Hint, hint. Crew members, do you notice anything cool in the sky? I'll give you direction more southwest of our view.
A lot of things actually. Two really large objects are particularly catching my eye because of size, but
yes, exactly. So these are pretty big. I would like to point out that Stellarium makes them pretty big. because of our settings, but these are two really bright objects. You will not miss them in the night sky as long as it's clear and you aren't standing right next to a street light. So what are these then? Did we say what these were?
I did not. I would actually like to redirect the question to Dayna, you know?
Okay.
Yeah, so one is a little bit bigger, which is indicating that it's going to be a little bit brighter than the other, right?
Mm-hmm.
And that one's the one that's closer to the horizon where the sky meets the ground. And that is Venus, right?
Yes.
Yeah.
That's the one. I've never been old enough or conscious enough, because maybe I was old enough, but I didn't have the planetarium knowledge and the astronomy knowledge to look up at the sky and notice. I've always seen Venus right before sunrise or right before sunset, and that's typical. That's normal. So this is really big, even though it seems so small because it's just Venus, but it's so cool because we'll see later on when we progress later in the evening, because it's, again, just after sunset. You can see this still if you have a clear horizon, no buildings or trees. You can still see Venus when it's night out and it's dark. I'm so excited.
Yeah. We often make these Harry Potter references, right? We always refer to Harry Potter, I feel like, in almost every episode, even in my planetarium presentations. We talk about Harry Potter. So there is one little reference to Harry Potter that I don't say too often, and it has to do with Venus. Do you know what I'm mentioning?
No.
It's like during his astrology test.
Oh.
He has to find Venus at midnight in the sky. Do you know why that's wrong? Why that will never happen?
Well, I would figure that Venus would be below the horizon at that time from our perspective, right?
Yeah, Venus is only visible right before sunrise or right after sunset, right? It's always visible near the sun in the sky. So you're not going to see it up high in the sky.
Yeah.
And you won't be able to see it at midnight. Yeah. So
Interesting.
not a accurate reference in the book.
And that happens. When I was a kid, there's all kinds of things that I believed in. Like, I thought I could look up at the sky and see the planets any time of day whenever I wanted, and all of them, including the very far ones like Uranus, Neptune, Pluto. And when I was a kid, I was told by my teacher once that the sky is blue because it's reflecting the ocean water, because ocean is blue. That is a misconception. That is not true. But it happens.
Yeah. I think I heard that as well. Yeah, we have this Earth in the way. Yeah.
Yeah.
Big
Yeah.
thing. Yeah, people come in, they want to see Earth in the sky sometimes in the planetarium, and I'm like, to see Earth, you're going to have to look down
Yeah.
at the ground.
Simply just go to the moon, then you'll be great.
Well, yeah, that works. That works great. One world, one sky with Big Bird. Big Bird can get you there
Bird.
with just your imagination. Come to a planetarium show at 3:30 if we're still showing Big Bird.
Unfortunately, we're not.
Darn it. But that's a classic here at the planetarium. We love that one.
We'll show it again. We'll show it again in the future.
Exactly. But I do believe that Kyree also has some follow-up points. But that's really, and the fact that it's in writing, it's in the book. I never knew that. That's why I'm still stuck on it. It's just the new information about the Venus thing with Harry Potter. So I'm just...
Yeah. I wanted to do Astronomy 101 and 3/4 for a long time. So I kind of had all the Harry Potter astronomy
that needs
tidbits in my head.
needs to be a thing. And this is not University of Chicago, but there is a smaller university in the city of Chicago that has like a bunch of classes on Harry Potter that count as like English classes. That should be a thing. But
Oh boy, that would be an interesting class to attend if I do say so myself. Self.
brain
But-
too fast. It's okay.
But like you did mention, I do have some really interesting things to chew on while thinking about Venus. So, as some of us may be familiar with, a lot of planets were based off of the major gods and goddesses of Roman mythology. So Jupiter, Venus, Mercury, all that fun stuff. And Venus herself, as in the goddess, not the actual planet, is the goddess of love, fertility, and really why we're just focusing on it for our good old Valentine's Day special. But I always find it so ironic that Venus happened to be called Venus. So some of you may not be familiar with it. Venus is actually the hottest planet within our solar system, with a surface that averages from 800 to 900 degrees Celsius. And I always make the stupid little joke that Venus is hot enough to boil water 8 times over because the boiling point of water is 100 Celsius, which is like
That's funny. I like that.
a dumb joke, but it is fun. It is fun to think about. And beyond just being really hot, it's affected by a runaway greenhouse gas effect. And that's really due to the 1,600 major volcanoes that Venus possesses, and potentially millions more smaller, minor volcanoes that's constantly emitting CO2 into the atmosphere and really creating this like super horrible greenhouse effect that's keeping all the heat trapped inside Venus. And the reason I just find it so ironic and hilarious is because Venus is the goddess of fertility, but you can't really have too much on Venus because it's too hot. So it's just something hilarious that I always like to chew on.
Yeah, so it has all of those volcanoes, and I think that there's studies that have shown that there are only like a few of those, maybe over 30, are active volcanoes on the surface. Yeah. So not all of them are active, but there's a lot of volcanoes.
There is a lot of volcanoes.
Like maybe over 1 million, which is just mind blowing. Yeah.
My brain barely had time to process the 00 after the 6, so 600. I was like, excuse me?
1,600.
1,600.
Okay, so I even misheard. Okay, too many. I don't like volcanoes. Fun fact, they scare me. They're very fascinating. Everyone always asked me as a kid, oh, you like astronomy? Why don't you want to be an astronaut? Don't you want to go out and see it with your real eyes and touch it? And I said, absolutely not. I am safe here. I know I can breathe here. I know I can live here. I will study safe here on my planet. Volcanoes are the same way. From a distance.
Well, Nicolette, you know that there's over 1,500 on Earth.
Yeah.
And we have more active volcanoes on Earth than we do Venus.
Yeah, and it's just so scary.
Then let's not
Venus is a little bit hotter, right?
And let's not forget the volcano in Yellowstone Park. And because of how large it is, if it ever just erupted, we'd be fundamentally screwed. And we're all the way up in the Midwest.
Yeah, it's a super volcano or something crazy. Yeah.
I'll need to contact Madeline for our regular viewers. Madeline also has hosted a couple of Constellation Crew episodes as a grad student. She's fabulous. And I went on a AAS, the American Astronomical Society conference meeting in Seattle in January. And her father came with, and he was talking about how one of the mountains in Seattle that I got to see once, because we had one clear day in Seattle, is actually like a dormant volcano. And if that one exploded, half the country would also be in big trouble. And I was like, I'm too close. I immediately was very uncomfortable after that point. He said, it's dormant, it's fine, don't worry about it. And I'm like, no, I want to go home. But we're okay, everything's fine. Volcanoes are far away from me at the moment, and I will keep it that way for as long as I can.
Okay, so the brighter of the two, or the one closer to the horizon, is Venus.
Right.
Yes.
But what's the other one? Kyree or Nicolette?
Jupiter.
Jupiter, yeah. So we have Jupiter and Venus visible right after sunset this time of the month. But what about if we fast forward through time? Can you shift the time in the simulation here? Just jump forward 1 day.
1 day.
Mm-hmm.
There you go. 1 day.
Yeah, see how they got a little bit closer? Because Venus is orbiting the sun.
Mm-hmm.
Jupiter, but a lot slower. Jupiter's way far away from the sun. Let's go even farther. Let's go another day. And just keep on going till maybe the 1st of March. And let's see what happens.
Oh. Whoa.
Yeah. So it looks like they're almost touching here in this simulation, but there's actually still a lot of space in between. Can you zoom in a little bit on them?
Yes, let me click on it.
There's about the width of the full moon in between them in the sky. But they're in what we call conjunction on the 1st of March coming up here in just a couple weeks, which is pretty cool.
It's
Yeah.
really cool, actually.
That is
So Venus
really
is
close.
a little lonely in the sky and it wants some company, so it's going to go hang out with Jupiter. But remember, they're really far away from each other in space. They just look like they're close together in the sky, right?
Right. For our viewers, I'm about to go backwards.
Yeah, the sky will never ever do this, by the
No.
way. Make some backup beeping truck noises if that helps you.
Beep, beep, beep. Well, there we go. We are back on the original date we started with.
Back to our normal time, safe and sound.
Our normal time, safe and sound, exactly. But I love planetary conjunctions. I just learned about them recently, and Madeline took a picture of one a long time ago. I'm going to have to ask her which one it was, because this happens with other planets as well. It's happened with Jupiter and Saturn before. So that might have been the one. That might have been the conjunction. So, but that one's the closest I've seen, but that might be Stellarium's simulation. We'll see. But very, very exciting. So the 1st of March, keep an eye out for that. And of course, until then, take a look at Venus, because I still think it's awesome that I can see Venus most of the night in the dark and not have to compete with the sun. It's nice.
Yeah. It can cast shadows too, it's super bright, yeah.
It's almost scary sometimes, because I don't know if any of our viewers have seen the Hubble space station fly across the sky before, and that one's pretty bright, but that makes sense. The Hubble space station, or Hubble space station.
Telescope.
Hubble
Yeah.
telescope. So the Hubble telescope and then the International Space Station. So I got them both confused. For clarity, I was talking about the
You just
International.
connected them because your brain is working faster than yours.
Use it
Correct. So the International Space Station is very close to us on Earth, and I have seen it glowing in the sky before, and I have seen it move. You can see it move across the sky in real time. And that one was pretty bright. And here I am, an astronomer going, UFO! UFO! And I had a grad student with me. His name is Alec. He's been on the Constellation Crew before as well. And he said, no, that's just the ISS. You're fine.
If you want to know when the next sighting of the International Space Station is, you can go to Spot the Station. Just do a Google search on Spot the Station. It's a NASA website, and it tells you when you can check it out.
That's
Good.
really cool.
Yeah.
Yeah.
Good to know.
Better than some of the applications I know some of our professors use. It's just way too complicated. Way too complicated.
Don't make it harder than it needs to be.
Everything is complicated.
I mean, fair. Life is hard.
No, I mean with them.
Also fair. But we do have some more to talk about today. We actually have something really interesting to talk about. We don't talk about this particular asterism often. Yes, and I specify asterism because we have our 88 official constellations, but pop quiz, is the Big Dipper a constellation?
It's not.
Correct. It is not. It is an asterism. So asterisms are also very, very common shapes that we have made in the night sky, and are commonly recognized all over the world in most cases. And they can either be made within a constellation. So, for example, the Big Dipper is a part of Ursa Major, the Big Bear. I know some asterisms are made up of multiple constellations. So, for example, we've talked about the Summer Triangle in depth on Constellation Crew many times, and that is made up of 3 constellations: 1 star from Cygnus the Swan, 1 star from Lyra the Harp, and 1 star from Aquilus?
Yes.
Aquila. Or
Aquila?
Aquila.
Aquila, thank you. That is the Eagle. So we're going to go actually to our good old friend Orion. So we're going to go starting south in the sky. And Orion is a very common shape, but it can sometimes be a little difficult. So we're going to try to look for 3 stars in nearly a straight line. And it's slightly diagonal. So for people who are super specific like me, it's slightly diagonal in the sky, but they're in a row together. 3 of them. I'm going to start south, and I'm just going to... Oh, I see some. Over here.
Yeah, I've had people tell me they can't find Orion, but they can find Orion's belt. That's the only thing they can find out of it.
Right. I that was me as a kid all the time. I could find this, Orion's belt, and that was it. But once you find the belt, you can actually use the belt to help you out here. So if you go towards the end here, you can go up to this really bright orangish star that is Betelgeuse or Betelgeuse. Some people say Betelgeuse. As many pronunciations, or common pronunciations I know of. We can go back down to the belt again, but then go in the opposite direction, and there's another star here. We can go to the other side of the belt and do the same thing. Go up, there's a star, and then go down, there's a star, and there you go. You have Orion's belt, his shoulders, and his feet or knees, depending on how you draw him. And of course, there's other parts of it, like the sword, and actually Orion is not just this rectangle shape here. There's more to Orion. He has some arms as well. But these are pretty bright stars that you'll most likely see in Muncie, and this is most likely most that you'll see is his feet or knees, his shoulders, his belt, and his sword. But what asterism is within Orion that we would like to talk about today?
And I'll go ahead and take that one. The asterism that is within Orion is not the sword that we're focusing on this time, but actually Venus's mirror. So, to easily find Venus's mirror, we're actually going to go right back to Orion's belt.
Awesome.
Orion's belt, so Venus' mirror is essentially kind of like a diamond in the sky. So we take that belt and then we go to the bottom left of the belt, so the third star in it,
okay,
and then make a sort of diagonal line to that blue star, which is the knee.
Oh.
And then, I missaid that.
Okay.
You literally just pass it. You're on this star right here, and then we're gonna make another diagonal upwards to that kind of faintish, like white-ish looking star.
Okay.
And then connect it right back to Orion's belt, and that itself is his mirror.
Oh, it's like a hand mirror. How pretty! That's so cute.
Yeah, and then part of the sword there is the little handle too underneath the diamond. Yeah, that's the handle of the mirror.
Wow.
And essentially, the point of this mirror is that both Venus and Aphrodite, two same goddesses, different spectrums of culture, Greek and Roman, they both had mirrors in which they looked at themselves. And because their whole thing of love also encompasses beauty, they're also sort of infatuated with their own beauty that they have within themselves. And actually, what's really cool is in paganism and witchcraft, what you would do is you would get a mirror and a red candle, and then because there are, I believe, 6 blue stars within the asterism and 1 white star, you would get 6 blue gemstones and 1 white quartz, and then place them in the fashion of the mirror, and then you would be able to peer into the mirror and find your true love.
Wow, I've never heard of that.
That's so pretty. Oh, it's so cute.
That's interesting. I always have loved this asterism because it's really fun to find in the sky, and it's not talked about too often, I don't feel. You get the summer triangle a lot, you get the winter hexagon, the Big Dipper, Little Dipper, those are really common. But Venus's mirror is just beautiful, I think, to find. And it's easy once you know where it is, yeah.
Yeah. I don't know about you all, but most of the time here in Muncie, all I really see, like I've said before, is Orion's shoulders, feet and knees, the belt, and most of the sword, if not all of it. Other than that, that's all the stars that I can really see, but Kyree did a fabulous job with showing us how to draw that square shape, and Dayna mentioned that Orion's sword, in this case for the asterism, will be the handle of the mirror. So if you can find the handle of the mirror and Orion's belt, you have one side of the mirror and the handle at the very least, and you can go from there. So, very, very cool. Love asterisms. They're very fun. We're going to talk about another constellation that is not talked about enough either, but I'm actually going to pull up the search here because this constellation is made up of very, very, very faint stars.
And I actually talk about it quite a bit in the planetarium because it's right behind Orion, and it almost looks like it's stabbing Orion in the armpit in our planetarium software in our planetarium. And I love it because, as Nicolette mentioned, it doesn't have a lot of bright stars. It's right between Sirius, the brightest star in the night sky. So if you follow Orion's belt down towards the horizon, you get to Sirius there, the brightest star in the night sky, the dog star. And then north of that, if you kind of go perpendicular from Orion's belt up or north, you get to Procyon, right there. Yeah, so between Procyon and Sirius is this constellation. And what is it called, Nicolette?
It's called Monoceros.
Monoceros. Yeah, so Monoceros, instead of 2 horns, it has 1 horn. So Monoceros, 1 horn.
Right.
What's the creature with 1 horn? Not a narwhal.
It's a unicorn. Oh, you can't see the unicorn. There it is. There's a unicorn.
A unicorn. And so my kind of joke in the planetarium is there's like nothing there that even resembles a unicorn. There's barely any stars there. Someone just really wanted a unicorn constellation and put it somewhere that you couldn't see anything.
You know, I can point out a unicorn if I stare really hard into Stellarium.
Yeah. Oh, we'll hit the search. Oh, it's not doing it in this one. In the dome, Monoceros is...
Yeah, it's angled so that it's right kind of at Betelgeuse there.
Let's see. Because I want to... There we go. Just turn it on for now. There's the lines. And in Constellation Crew before, so there's different ways to look at constellations. Of course, you can just go to Google Images, or if you are familiar with Sky Maps draws the connect the dots with the constellations and has their own stick figure version. And that tends to be different than in Stellarium. So I hope that this is roughly the same compared to Sky Maps, because I know that, what's the one that's drawn differently? Andromeda. Andromeda's drawn differently for me. And Capricornus. Capricornus to me looks like a scone shape when you play the connect the dots, and it does not look like a scone in here. But our beautiful unicorn in the sky. So we've talked about this particular constellation before, and it's really funny here at the planetarium because I love looking at it, like Dayna said, when it appears to be stabbing Orion in the armpit, just not in this case. And of course, who doesn't love a super awesome unicorn? They're so fluffy, quoting Agnes from Despicable Me. They are just really beautiful, majestic creatures. And surprisingly, this came about from, let's see here, I believe it was a Dutch astronomer. He introduced the name, and I believe it was influenced by biblical references. And I say believe and not for certain, because this constellation, again, its myth is not really connected to concrete culture or evidence. So Orion, that screams Greek and Roman mythology, right? We can connect that right back, and it has a lot of myths. Orion has tons of myths. Orion the Hunter is super famous. But Monoceros is just a unicorn in the sky, right? So, but it's not just a unicorn in the sky. A Dutch astronomer did discover it and introduce it, but it is unclear as to why a unicorn, why Monoceros, and why here. All of that is really kind of just probably been lost in history. It wasn't written down or wasn't spoken about enough, which tends to happen on occasion.
At least it's safe from Professor Quirrell.
Yes. But this unicorn is not just epic by itself. There is something cool in the constellation itself, and it has to do with Valentine's Day. Let's see if I can pull that back up and see if it has a picture. It meaning Stellarium. Nope. Crew members, I don't know how to spell. Oh, I have to type it out all the way, as per usual. There we go. Let's see if there's a picture. Wow. Should zoom in some more.
I think it should be called Noza now because it was in the unicorn's nose.
Yes. I was just about to ask our crew members what this name was, but I did type it up, so they did definitely get a cheat, and I'm particularly slow because I can't spell. Yes, this is the Rosette Nebula, and I love the colors. I love that it sort of looks like a rose to me. The more I focus on it, the more I start to lose it, and it becomes a cloud again. But if you kind of just sit back and relax, yeah, you can see the rose, or for guidance, I see a center of the rose here because it's darker in the middle, and then I start to see some petals here because there's a lighter pink magenta rings around and start making some petals. It's absolutely beautiful, especially with all the stars in the middle. And this is more specifically an emission nebula. So to put it simply, an emission nebula is just a nebula, clouds of gas and dust all mixing together. But there's a bunch of stars within this nebula that are exciting the molecules and gases and dust around it to make it a specific color. I'm going to pause the sky because it's slowly moving. There we go. But when that happens, nebulas can become different colors. In this case, the stars are exciting hydrogen gas, and that's why it's a reddish color. That's all really an emission nebula means. It means that the stars are having a party and they're exciting the gas around it. And now they're changing colors. But
it's not like the gas is reflecting light, like what we're used to, light kind of reflected from objects, and that's how we see the world around us. It's a different type of process that makes it light up. Yeah. So it makes red really kind of indicates the hydrogen, and we kind of learned that in other episodes. And hydrogen, we know, is the most abundant element in the universe. What's the second most abundant element? I'm curious to
sometimes this is a trick question. I'm gonna guess helium.
And it's not a quiz. I'm just curious to know what you think, honestly. I mean, there is an actual answer, but yeah, it is helium.
Okay.
So the most abundant element in our universe is hydrogen. Mm-hmm. Then it's helium. And so that makes sense, right? Like stars are made up of hydrogen and then they fuse that into helium. And so there's a lot of it in the universe. Mm-hmm. What's the third one though?
Carbon.
That's the fourth.
Really? I was so strong on that too. Okay. Yeah. Oxygen?
It is oxygen. Yeah. Great job. Yeah. So oxygen is the third, and that might surprise some people. So yeah.
Well, I've heard before that breathing pure oxygen is actually not good for you long term.
Yes.
I've heard pure oxygen, just straight.
Yes, breathing pure oxygen is like kind of toxic for you in the long term, but it is utilized in critical situations where your life is in danger.
Right.
Like when you're in an ambulance, you will be given pure oxygen.
Exactly. And it is beneficial. Grey's Anatomy is not real medical practice. I would like to make that very clear. Some of it is true, some of it is not. My nursing friends and doctor friends can definitely attest to that. But in Grey's Anatomy, they do talk about that and how a lot of times when there's a fire, you're usually put on pure oxygen to help in case you've inhaled some smoke. But this is the beautiful Rosette Nebula. I almost don't want to leave, but we have more objects to talk about really briefly. This nebula actually has a star cluster in it. And of course, in astronomy, we have really awesome names, and this star cluster's name is NGC 2244. Very creative. So it's an open star cluster, and we've talked about those before. Loosely bound stars that were born of the same cloud, gas, and dust. So most theorize that the open star cluster was formed using most of the material from the Rosette Nebula. That's why it's in it. And when you use the same materials, most of the stars are born all around the same time, roughly, give or take a million years. Some take longer than others, that's fine. And they are just hanging out inside of this nebula now. And that's what most of these really bright, pretty ones are, or at least I would believe. Because sometimes pictures with astronomy, perspective is key. Sometimes stars photobomb and they're not actually supposed to be there.
Very true. Yeah. Sometimes it's really obvious. Sometimes it's a little bit harder to tell.
Right. But
yes, we talked about like open star clusters, which that was, and then we've talked about globular star clusters before. And so those are really interesting features. And globular star clusters actually kind of helped back in like the early 1900s them understand the shape of our galaxy. They found that globular star clusters were around the galactic core, kind of distributed evenly in a spherical fashion, and that actually allowed them to pinpoint the center of our Milky Way galaxy. I mean, you know where the center of our Milky Way galaxy is, right?
Not necessarily
Yeah.
specifically, but yes.
The constellation that it's in.
Oh yeah, I believe
This
so.
constellation that it's in is
Sagittarius.
Yep, Sagittarius. So it's not, where Earth. It's not near Earth, and so they were able to pinpoint that back in the early 1900s, which was really cool, with globular star clusters. So I always found that fascinating.
Wow.
Yeah. So I mean, like, pretty pictures for sure. Pretty pictures for sure.
Yeah.
But there's science behind it.
And that's like the best part. And I love that every object in astronomy is important and has meaning. Some people like to joke, but everything in astronomy is very vital and important and can help out with a lot of complex things.
Yeah, I like that there's a story behind almost every single object out there.
Exactly. The stories never end. Millions of options, literally. We have more to talk about still. We have some more love in the air, or love in the sky, if you will. We're going to actually go north, so I'm going to do some spinning. For our viewers, I apologize. I'm spinning. I'm going to try to spin gently. We're going to go north. We're going to look up in our sky, and I'm going to try to see if I can find my familiar shape. I have spotted the Big Dipper. Oh, there's the shape I was looking for. But here's the Big Dipper, our good old friend. We are looking for the constellation Cassiopeia, which we have talked about on Constellation Crew before. But for our crew members here, what shape am I looking for when I talk about Cassiopeia?
I'm probably going to think of the wrong one. Is it a W?
Well, right now it looks like an M to me, but I'm not sure if it's on the screen for the recording.
It is partially in view. Thank you. Now it's in view.
Yeah, it kind of looks like an M.
Yeah, I agree.
Yep. Usually Melanie will say M for Melanie, our planetarium show specialist.
I'll choose a W for a win.
I was going to say W for Wyatt, but okay. But exactly right. But Kyree is also Kyree is also not wrong. Cassiopeia can be a W. So the funny thing about Cassiopeia, the constellation, is that it is circumpolar. Big word. All that really means is that if we were to accelerate time, which I can do that for you in a moment, it'll spin in a circle. Or lack thereof, a circle. So let's do that.
Sure. Maybe turn off the atmosphere.
Okay. Is that A?
Mm-hmm.
Perfect. But
try again.
Oh. Mm-mm.
Click it.
There we go.
There we go.
But now we're in March, more specifically March 2nd. And
Nicolette, could you show how to find Cassiopeia?
Oh, sure. Definitely. How can you see it rotating if you don't know where it is in the sky and I haven't shown you how to find it? So I'll turn the atmosphere back on really quick.
Yeah, because sometimes it looks like an M, sometimes it looks like a W, but it could also look like a 3 or an E.
Right. Usually how I do it, and it's not the greatest method, but I'll go back to my good old friend, the Big Dipper. And the Big Dipper has a handy dandy tool at the end of its spoon, are these two stars here. These two stars are used to find a lot of things. But in this case, we're going to use it to find Cassiopeia. So I'm going to use the two stars and just draw a line across the sky. Keep going until I get to a bright-ish star here. And then you can start forming an M or a W from there. Now, even though this constellation is circumpolar, because the Ursa Major is also very close to the North Star, constellations that are closer to the North Star are the ones, at least in our perspective in the Northern Hemisphere, tend to circle around it in that fashion. So don't worry about Ursa Major disappearing or the Big Dipper. It'll be there and circle with Cassiopeia. So again, you'll find those two stars and draw a line up until you find a brightish star here and form that M. And on my journey there's this bright star here. Well, bright.
Just between, yeah.
Yeah, this star here. What star is this?
That's Polaris, the North Star.
Exactly. So I pointed out because it's fun, and in this program, it looks particularly bright, but in some cases, like here on campus, it can be particularly hard to see because of all the lights.
Yes.
It's better to see in a very dark place, and Polaris is not the brightest star in our sky. That's also a common misconception. That's Dayna mentioned Sirius was the brightest star in our sky, and many others. But I just thought I'd point it out since it was on our journey, and I don't want to rely on the North Star since I might not be able to see it as good as the two stars here in Cassiopeia.
Yeah, and just a quick note, like even though most of the stars in the Big Dipper are circumpolar, so always visible, sometimes it does get pretty low in the sky and it is really hard to see. And so if you do use it to find Cassiopeia, you'll notice that Cassiopeia is going to be highest in the sky when the Big Dipper is lowest in the sky. So if you can find the shape of the M in the sky or the W, or just look for that pattern, and Nicolette, can you just trace out that pattern or maybe put up the lines for it? You can really spot it pretty easily.
There you go.
Yeah, so look for that kind of shape there. They're relatively bright, especially with light pollution here on campus. So if you can find the spoon shape in the sky, you can hopefully find this kind of pattern too, even without the Big Dipper as a guide.
Well, thank you. That's actually very helpful for me. I did not know that.
Yeah, so let's go through the time. So don't do the date, do the time instead here.
Oh, the time? Okay. So
yeah, go hour by hour.
There
so
we go.
So we're jumping time hour by hour, and so when the Big Dipper gets high in the sky, it's going to get pretty low in the sky. So this is after midnight here in Muncie.
Yep. And Big Dipper's there. And Cassiopeia, we're going to trace him down again. Say hi to our buddy, the North Star. There's Cassiopeia. Now it's a 3. Is it a 3? No, it's an E.
It's an E.
I get those backwards.
I believe you. I was just like, yeah, it's a 3.
Yeah. I want
just flip the paper over. A 3.
Yeah. Everything's mirrored in Zoom sometimes too, so.
That is also true. But I am naturally just very clumsy in the regard of speaking and shapes and symbols.
Oh, yeah.
But now that we found Cassiopeia, so I'm going to do a bit of 2 birds with 1 stone here. And the constellation itself has a really awesome object on the inside, also relating to love, Valentine's Day, called the Heart Nebula. So I'm going to pull that up for you all. See, I have to type it all the way out because I can't just click it and let's forget that. There. And see how it's a nice little queen, and she is a queen, and the myth we will discuss in just a moment here. And I'm actually...
Now that looks like a heart.
This is a much better image than some of the images that I was looking at previously to prepare myself. This is much better. I like this one much better than some of the other ones I've seen.
I really do see the heart, but I also do see kind of a goldfish here. Just like really like bent.
Like the kind you eat?
Yep.
Oh!
Like you have the head, and like left side, and then like it's kind of bent, but like you have like the 2 tails.
Yeah, it's like swimming away from you so you don't eat it. Yeah.
That's so cute. I love it. Well, this Heart Nebula also has a very creative name, of course, the Heart Nebula, but it also has another name, again, very creative, IC1805. Very weird. Very interesting.
It looks like it's also called the Valentine Nebula.
Yeah, which is interesting. This is sometimes if you are like going around on the internet, and I've done this before because I am a space nerd at heart, and I was looking for ideas to spend Valentine's Day with my family or with my gal pals on like astronomy stuff. Like what can we do space related for Valentine's Day since we love space? And this is a very common object that pops up is the Heart Nebula, sometimes I guess called the Valentine Nebula because all the hearts. So I'm actually going to draw out the heart here because I know I've looked at images and they're like, don't you see the image, whatever the image is, a person, a woman. I never see it. And it's those trick ones where you can see multiple objects in them. So here's part of the heart. And I'm just gonna, like, this to me looks like a goldfish down here.
Like a
And
real one.
But we got the small side here. And then we're gonna go back up to the corner. And another side here.
Like the heart drawn by a middle schooler.
I was just about to say the hearts that I used to draw when I was a kid. So, great minds think alike. But the Heart Nebula is, once again, an emission nebula. We saw the Rosette Nebula, and it looks very, very similar. That is because they are of the same type. They are an emission nebula. There are also is a open star cluster in here as well. But yeah, it's just really cute. Hearts are everywhere, and I love it. And again, it's red due to the excited hydrogen gas.
It's pretty far away, right?
It is very, very far away. It is 7,500 light years away. And I believe, I don't know the specific number, but there are trillions of miles in a light year.
Yeah, there are trillions of miles in a light year. There's 6 trillion miles in a light year.
6
Yeah,
trillion.
Yeah, so really far away.
Very
So the Heart Nebula is actually in the what we call the Perseus arm. So we have the Milky Way galaxy, and it has all these kind of spiral features. Those are spiral arms, and they're named so we can keep track of them. So we have the Perseus arm, which is one of 2 major spiral arms of the Milky Way galaxy. The second. Go ahead.
Here, Nicolette, what is the second one?
The second one?
Any guesses?
The second one what?
The second arm. The second major arm.
For the Milky Way that I was just about to spoil.
I don't know.
It's 2 constellations. The Shield constellation and the Half Guy, Half Horse constellation.
So then...
Well,
Sagittarius and... No?
No,
Nope.
The other one.
Centaurus. It's Centaurus.
Oh!
Yeah, it's a bit tricky.
Okay.
And then the Shield is... We did a variable star episode about this.
Oh, okay. Gotta think now. If you can't see I'm going through my filing cabinet in my brain. That SpongeBob episode is happening at the moment. But they can't find anything. I have no idea. I don't know what that one is.
Forgive my probably horrible pronunciation of it, but Scutum?
Yep.
What?
Scutum.
Scutum.
Okay.
Let's scoot over.
And Centaurus. That's the other arm, the other major one. So the heart is in the Perseus one.
Interesting.
But where's the sun?
It's located in the middle of our solar system.
Yeah. It's in a spur. It's in like an arm or like a spur.
Mm-hmm.
Like a little spur, maybe not a complete arm, but some people still call it an arm.
Oh, okay.
Okay.
It's 2 other constellations. We've talked about both today.
We talked about Orion.
We talked about
That's one of them.
Orion, and then we talked about Cassiopeia.
The other one isn't up in the sky right now, but we talked about it because it's a part of a common asterism.
Oh,
Ursa Major.
Okay. That's
well, I know that was up in the sky when we were messing around and finding Cassiopeia, but
it's in the summer triangle.
Oh,
Aquila.
Oh, you're doing guess and check now. You're doing guess and check. So
yep, guess and check.
So no.
Lyra.
Not Lyra.
Okay, so then Cygnus.
The Cygnus, yeah. So Orion's Cygnus arm is where the sun is located, and the Milky Way. Yeah. So all this to say is the Heart Nebula is really far away in what we call the Perseus arm, one of the 2 major spiral arms in the Milky Way. There's another one called the Scutum Centaurus arm, and then the sun is in a little spur or arm we call the Orion Cygnus arm.
Wow.
Yeah.
See, this is why constellations are important.
Exactly.
This is why we study constellations.
I still think we should get shifted over to the Aquila Orion since that was the perfect guess.
Oh, are they right next door to each other? Well, I was just about to zoom out to talk about our other object, which is the anti-version of the object I just spoke about, because there's more in Cassiopeia. But before we go there, and let me actually just click on it and figure this out. I think it is, but I don't know how to click on it to know for certain because I can't click the image.
I think it's because it's the same thing almost. Like it's the same region, maybe?
Yeah, most likely. Let's do a search and check really quick. But in the meantime, Cassiopeia has a very interesting history in Greek mythology, and we've talked about Cassiopeia before. But Cassiopeia is not up here of her own free will. She's actually in trouble, and that is because she was a queen in Greek mythology, and she thought that she could say out loud and proudly that she is more beautiful than the goddess Hera. And Hera is the goddess of all the gods and goddesses. She's kind of like the queen of them all, right? She's Zeus's wife, right? If I remember correctly? Yes, she's the queen of the gods and goddesses. She is Zeus's wife. So Hera did not like that very much, and quite frankly, neither would I if I was in her position. And so she decided to put Cassiopeia up in the sky, and that is why Cassiopeia is circumpolar. Or that's what I like to say. But the myth goes that the reason why that Cassiopeia is circumpolar is because she's spinning around and sometimes she's upside down.
Having to hold on to her throne.
Exactly right. But not all hope is lost. This is the love episode, so there is more to come. But before we talk about the rest of that love story, let's see. Cluster. Don't know if that's the right one.
Try NGC 896, or you could also try the fish head.
Yes. Let's try that. And let me put the atmosphere back on and figure out where I am. So here we go. North, Big Dipper, Cassiopeia. Awesome. Back to our regularly scheduled program. So what was it? NGC?
You can try NGC 896. You could also try, I believe, the fish head.
Oh, this works. Perfect. And my suspicions were not true. Oh!
No, same. It's the same image. I think it is the broken heart right there. Yeah.
Okay.
Yes.
So it's the part that I thought that looked like a fish.
Yes.
Awesome. Well,
yeah, so, it's interesting because sometimes it's like one little component of the larger thing, and you're trying to figure out what component that is. Because some of the pictures, they look completely different depending on the filters they use, the processing they did on it. Yeah.
And I'll take the atmosphere back off. There we go. Ooh, brighter red. But as our viewers probably guessed, this is called the Broken Heart Nebula, or apparently there's a Broken Heart cluster, which I need to know more about that. But we are not here for that. We are here for the Broken Heart Nebula, but Dayna did mention that it's kind of a smaller piece of a bigger picture, but I believe Kyree will tell us more as well about this particular piece of the puzzle.
Oh, yep. The Broken Heart Nebula, also known as the Fishhead Nebula, is literally named because someone before Nicolette got Nicolette's brain and then called it the Fishhead Nebula. Kind of looks like a Fishhead Nebula. It also does kind of look like half of a broken heart if you just kind of like flip your head over and like really stare at it. And it also is a great way for me to send my wishes to everyone to hope that they've had a good Valentine's Day, and if they didn't, if someone broke their heart, fight them.
This area in space has everything. It has the heart, it has the broken heart. It's like something for everyone.
Exactly.
Okay, so I thought of something really mean. And sometimes on like TV or there's like this running thing of if a girl knows that, or if anyone knows that someone is going to ask them out and they don't know how they feel about it, they're in the middle. Sometimes they prepare for both. Or here's a better example. Sheldon Cooper had to buy a gift for Amy Farrah Fowler for the first time once for Christmas or birthday, and he bought all different levels of baskets filled with trinkets and things and girl stuff, and it ranged from the cheapest basket he could find to the most expensive. He wanted to prepare himself and oh no, it wasn't Amy, it was Penny. So Penny, he wanted to get Penny's gift first because he wanted to know how expensive it was. He was prepared for either scenario. So in this case, if you don't know how your Valentine's Day is going to go, you can either show the Heart Nebula or the Broken Heart. At least they're all in the same place. That makes it pretty easy. But we still have more to our love story to talk about. So we have our queen, Cassiopeia. And I'm going to turn the atmosphere back on to get our realistic sky back. So now we have to look for her husband, her loving husband, King Cepheus. So Cepheus is actually interesting because everyone says that it was a house shape in the sky. I never saw a house shape. I saw a man with a hat. That's what I saw. But can anyone see that hat shape in the sky? Get rid of our friend Cassiopeia. Have we found the house?
It's a great question. Have I found the house right now?
Our house. I'm kidding. I think I found it, but I'm also notorious for being wrong. But that's okay. Let's give it a shot. I think it's here. Is our little house shape?
Yeah, but you got Polaris in there.
Oh, I do have Polaris in there. Am I backwards then? Oh, so I'm most of the way there. So let's click on it and see. There we go. And I'll turn the lines on. Oh, wow. So yeah, I made a shape in the sky that did not exist. We love that. I was close.
We'll call it the Nicolette asterism.
There you go. So King Cepheus is Cassiopeia's husband, and the legend goes that Cepheus was very, very, very sad to be separated from his loving queen and wife who was sent to the sky without him, and he pleaded with Zeus. He's like, I have to be with her. I love her. I can't be without her. I just can't stare at her in the sky. I need to be with her. And Zeus was reluctant, but I think he got kind of annoyed with all of the begging and pleading because the story goes that Cepheus was relentless with asking Zeus about this until eventually Zeus abided, and they are now in the sky together because our friend Cassiopeia is right next door. But to prove my point, man's head and then his hat. That's what I've always seen. I see a house too. That's how I used to draw houses as a kid. But when I first saw this constellation without realizing it's an official constellation as a kid, I saw a man's head and a hat.
Interesting.
Kind of interesting that the house is backwards. I would figure that the point is more towards the drawing's head. But these are drawings. I don't know about you all, but I don't have the imagination power to see this in the night sky. I wish I could. It would be a lot more fun and entertaining. But either way, this is definitely just the illustration. How cute. Two twin lovers in the sky. So if you're looking for a cute romantic story in the sky, feel free to check out Cepheus and Cassiopeia. So once you found Cassiopeia, you can just check out next door. You can try left or right, but either way, check next door to look for that house shape or man with a hat, however you choose to find them. You can also use the Big Dipper once again if you so choose, the 2 stars. And you can find the point of the house. Any comments on Cepheus or Cassiopeia before we wave goodbye to the husband and wife in the sky?
No.
No, you got it.
On one final note, before we do a quick Q&A with Dayna, I would like to mention that our beloved dwarf planet Pluto is still very special for Valentine's Day. And I believe both Dayna and Melanie have said this in the dome. It's so cute. But I hear Melanie say it often when people ask to see Pluto. Our celestial buddy here, Pluto, and the moon, the moon, Pluto's moon. See,
It's moon, yeah.
Yeah, be very careful when you say the moon.
Ish, yeah.
But if you can see on our celestial buddy, there's a little heart shape here. And you can see that on Pluto itself. The celestial buddies are really great at doing mostly accurate representations of the planets and having cute little characteristics on them. In Pluto's case, it's that cute little heart shape that is on the planet Pluto with a nice high resolution image. Feel free to ask about it in the planetarium. We do have a picture of Pluto to show that. But the hearts are everywhere. And back to the Melanie's point is that sometimes she'll say that Pluto has the heart on his tummy to show us that he forgives us for not calling them a dwarf planet. when they were initially a dwarf planet. All is forgiven. All is forgiven.
That's a good way to put it. Yeah, I thought it was going to go
a different direction.
Yeah, Pluto was probably really upset that we called it a planet for so long when it was actually a dwarf planet.
Yeah.
Right. Yeah, that's the point. Yeah. So Pluto's attached to a moon, the largest moon, Charon there. Mm-hmm. But it actually has 5 moons. Pluto has 5 moons, which is pretty cool.
Wow.
And so do you know what that heart shape is made out of on Pluto?
My guess would be ice.
Yeah, it's frozen. But what frozen material?
Oh.
What frozen?
Oh.
So then it's not water. Because if it's mixed on ice,
it makes up 80% of our atmosphere.
Nitrogen.
Nitrogen, yeah. So that's frozen nitrogen. And so like when you look at Pluto and you see that object, the dwarf planet, and that heart shape, did you notice any like craters in that image?
When I saw the image in the dome, yeah. So on the plushie itself, it's very clean, right? It's very distinct. But in the image, you can actually see more textures.
You can see a couple maybe like 1 or 2 craters on it in the dome, in the high res image that we'll show. But really it's really clean. And so when you see smooth areas on objects in space, you know that there's geological activity. So going back to geology, that's really interesting. Like that, a dwarf planet, something that's really far away from the sun, really cold, so cold that nitrogen freezes, can have geological activity that will erase craters over time, because like if a surface is old, it's going to get hit and it's going to keep that activity, that kind of history of the craters on its surface. But if it has geological activity like water erosion, volcanic activity, stuff like that to erase craters over time, we just don't see them, right? So what happens to Pluto? And they say that during the day that thin layer of nitrogen ice warms up and it turns into vapor. And then at night it condenses and it forms ice again. And they actually say this, it's like a heartbeat.
Oh, yeah. Oh, that's so cute.
Kind of pumping nitrogen winds around Pluto. So, yeah.
Love truly is in the air and in the stars. I love it. Based on this episode alone, crew, what kind of genre books do I read? Take a game.
Romance?
Ding, ding. There you go. I'm a sucker for love. What can I say? But that is really, really cool. I love learning new things about Pluto. And now I can't look Pluto any differently. I have my own set of celestial buddies back in my dorm, and I will gladly be taking Pluto around after hearing that.
Because look at our moon. Our moon has tons of craters on it. It just has no geological activity to erase them.
Right.
But I mean, Pluto has activity.
Yeah.
Our moon, not so much.
Mm.
It's cool. Pluto's cool.
It's okay to be a little basic, Mom.
But with that being said, that's just about most of the constellation content that we have for our show today. Does anyone on the crew have any final thoughts or comments or anything they would like to see before?
None for me.
Alrighty then. Time for the most exciting part, I believe, for this episode, and it's the Q&A portion. But we will try our best to keep this short and sweet because I know that we all have places to be. So, first question, or I'll do 2 questions at once. What is your favorite constellation and why? And what is your favorite astronomical object and why?
Okay, so we'll try to do this lightning quick. Favorite constellation, probably Cygnus the Swan, because it's one of the first ones that I learned besides the most common ones like the constellation Ursa Major, Orion the Hunter. So Cygnus the Swan is really easy to find in the sky. It actually looks like what it should look like, which is a swan. And it, again, was one of the first ones I learned besides the most popular ones. So it kind of has a special spot in my heart. And then it has something really cool in it called Alberio, which looks like one star to us. But if you point a telescope at it, it's actually 2 stars. And one has this really kind of golden hue. It looks orange and gold. and then the other one is a really bright blue. And so even in kind of a basic telescope, you can see the color difference in these two stars, which is just really amazing. But that's not my favorite astronomical object. It's one of them. Probably favorite astronomical object is the Orion Nebula, because you can see it without any optical aid, and it's really big, really cool. A lot of great images and data visualization that we have are of Orion.
I would agree. Really quickly, I can spin around, and I didn't notice this until I started working at the planetarium as well. You can't really see it in our simulation, but I can at least give everyone a reference. We're going to go back to the sword of Orion here. And the middle one, as long as I'm still in frame, the middle star, point of light, is the Orion Nebula, and I can confirm in the dome and outside of the dome, it looks a bit fuzzy. That's the Orion Nebula. That fuzziness you're seeing is the nebula. That's so cool. So I can respect that is your favorite object. Awesome. My final question is, what would you say to either younger you or young viewers that are currently watching this episode about getting into the astronomy field?
That is an interesting thing to think about for younger me. I think for younger viewers in general, is just to keep exploring, and it can be exploring anything that you're passionate about that week. And sometimes you have to start learning about something to become excited about it. I find that I'm most excited about the thing that I'm learning more and more about. People often ask, what's my favorite planet? And it's usually the one I'm studying that week. So if I'm looking into Jupiter more and learning more about it, I realize that I'm getting more excited about it because I'm learning all these interesting things about it that I never knew before. So you might surprise yourself when you start learning about something you thought you might not have been interested in before. So just stay curious and keep learning about all different things, not just space. We talked about the arts at the beginning of the episode, but geology too. There's so many cool things to learn about in the world.
Awesome. I agree. Well, I know that Kyree also has some questions. Would you like to ask them, or I can ask them for you?
You can go ahead and ask them. You tried to deflect your younger you, but I think we should go right back to it. What is one thing that you wish you knew before you even went into the field of astronomy, into the field of planetarium work, all that?
Yes, I did try to deflect that. Very great observation. One thing I wish I knew before joining the astronomy field. You know what? I really, I've had time to think about this, and I'm not sure I can think of it. I think that I have just kind of gone along for the ride. I was hardworking. I was fortunate to have parents that showed me by example that you had to work hard every single day, even on the weekends, to do what you needed to do in life and to achieve the things you wanted to accomplish. So I was fortunate to have that. And I think that if people aren't fortunate to have that growing up or in their early stages of their professional careers, to find healthy mentors who can provide that for them. And so I guess maybe if the one thing that I wish maybe I could have known or could have known more is that to surround yourself with to purposefully surround yourself with healthy mentors, and that there's always more people than the people that are at your current institution out there. So if you can't find someone at your current institution, you can always reach out to other places. The world is very big.
Very nice, very nice. Would you like to ask the final question, Kyree, since I asked 2 questions?
Of course. And then how do you stay motivated in the field?
Yeah, so this is a question that I typically ask other people because I'm always interested in what keeps them motivated. And for me, I just remember that it's an everyday effort. Every day you have to show up and work your best, work your hardest, because it never ends. You have to continue to kind of put your best foot forward. And what kind of helps me stay motivated is to remember to not get comfortable. So that's another kind of piece of advice that I would give people, is just to not get comfortable, to keep challenging yourself. So I try to challenge myself, whether that's to prove people's opinions about me wrong, or even my own opinions about me or my negative thoughts about myself wrong, because sometimes we can be our own worst critics, you know. So just remembering that it's an everyday effort, and to not get comfortable kind of goes a long way in staying motivated. And then the people around me, the school groups coming in, the public coming in, that's always motivating. When I know we have groups coming in, I get energized from that. Having Constellation Crew today was definitely energizing, and puts me in a better mood for sure. So that motivates me as well.
I really like that prospect of keeping days as individual instances, you know?
Yeah. It's someone kind of gave me that advice. One of my friends and mentors a couple years ago. Sometimes we put these timelines on ourselves, these grand timelines, and it's like, well, what are you doing right now? Like, think about what you're doing right now, or what are you doing today? And today I'm working on this, and kind of break it up into a daily activity or even an hourly activity.
That sounds like a lot about the man that got me into astronomy. His name is Hakeem. His last name is a bit odd, so I apologize, Hakeem. I know that we've met. I had the privilege of meeting you, and I apologize for not pronouncing your last name correctly. But it starts with an O, so if you're interested, definitely look him up. So Hakeem O. Azuli. That's definitely not how you say it. I apologize. But he shared some advice with me as well when we had the privilege of meeting. And he said something very similar, that sometimes you can get stuck in this timeline of month to month or year to year instead of day to day. So then you're speeding through and missing some stuff and missing day to day, because you'd be surprised how much one-tracked mind can like shrink your world a little bit and get yourself stuck in just you and what's going on. And sometimes that's not always great, because then you start focusing too much on other issues that can arise that way. And he always told me, or at least he mentioned with me, the 3 best ways to ground yourself in the moment is to list 3 things you see, list 3 things you can touch, and then 3 parts of your body to ground yourself in the moment.
Yeah, there's some grounding techniques, and sometimes it's like one thing you can taste, 2 things you can smell, 3 things you can touch, 4 things you can hear, and 5 things you can see.
Mm-hmm.
So there's lots of different series to it to help with that. Yeah,
that's a good one to remember. I've fallen for that trap many times, and I'm happy to report that I'm back to my day-to-day timeline. Love that one. It's the best one. You get most out of life that way. All right. Well, thank you very much, Dayna, for joining us. It's been a privilege having you on Constellation Crew again. I know that you're super awesome busy, but you're doing amazing things at the planetarium. So we appreciate you taking some time to be our special guest today.
Thanks, Nicolette and Kyree, for having me.
This upcoming weekend, we do not have any public shows, I believe. So, but important thing to note, we're going through a change in our show. So I mentioned earlier that we talked about Big Bird and One World, One Sky. We are no longer showing that as a kids program for now. At 3:30 on Saturdays, we are switching to new shows. I do not have them on hand, but I can guarantee you they are absolutely amazing. I've seen almost every single one here at the Charles W. Brown Planetarium, and all of them are great and have amazing lessons to teach you. So any show will do. I highly recommend going to any of them.
Yeah, and we have some new ones coming up. We have Birth of Planet Earth premiering next weekend, not this weekend, like Nicolette said. And that's all available on our website, on our social media channels. So check us out there.
Exactly right. Yes, please check us out on those. We would love to see you guys in the comments or on our websites, rating us on anything. We love to see you guys and to hear from you guys at any point, whether that's at the Dome itself or on Facebook, on Instagram, on YouTube. Please feel free to comment on this video. We love reading them. But with that being said, are there any final thoughts before we say goodbye?
None from me. Any from you, Dan?
No, keep looking up.
Exactly. Keep looking up. You'll always find new things. And love is as well as in the air, as well as in our stars. Same thing. Thank you so much for joining us today. And I hope you guys have a wonderful week. And we will see you next time. Bye-bye.
Bye, everyone.
Have a great day.